It is actually a reality today that you can download products from the web, product data, I should say, from the web, perhaps tweak it and personalize it to your own preference or your own taste, and have that information sent to a desktop machine that will fabricate it for you on the spot. We can actually build for you very rapidly a physical object. And the reason we can do this is through an emerging technology called additive manufacturing, or 3D printing. This is a 3D printer. They have been around for almost 30 years now, which is quite amazing to think of, but they're only just starting to filter into the public arena. Typically, you would take data, like the data of a pen here, which would be a geometric representation of that product in 3D, and we would pass that data with material into a machine, and a process that would happen in the machine would mean layer by layer that product would be built, and we could take out the physical product ready to use, or perhaps to assemble into something else. But if these machines have been around for almost 30 years, why don't we know about them? Because typically they've been too inefficient, inaccessible, they've not been fast enough, they've been quite expensive. But today, it is becoming a reality that they are now becoming accessible. Many barriers are breaking down. That means that you guys will soon be able to access one of these machines, if not this minute. And it will change and disrupt the landscape of manufacturing, and most certainly our lives, our businesses, and the lives of our children. So how does it work? It typically reads CAD data, which is product design data created on professional product design programs. And here you can see an engineer, it could be an architect or a professional product designer, create a product in 3D. And this data gets sent to a machine that slices the data into two-dimensional representation of that product all the way through, almost like slicing it like salami. And that data, layer by layer, gets past the machine, starting at the base of the product and depositing material, layer upon layer, infusing the new layer of material to the old layer in an additive process. And this material that's deposited either starts as a liquid form or a material powder form. And the bonding process can happen by either melting and depositing, or depositing then melting. In this case, we can see a laser sintering machine developed by EOS is actually using a laser to fuse the new layer of material to the old layer. And over time, quite rapidly, actually, in a number of hours, we can build a physical product ready to take out of the machine and use. This is quite an extraordinary idea, but it is reality today. So all of these products that you can see on the screen were made in the same way. They were all 3D printed. And you can see they're ranging from shoes, rings that were made out of stainless steel, phone covers out of plastic, all the way through to spinal implants, for example, that were created out of medical-grade titanium, and engine parts. But what you'll notice about all of these products is they're very, very intricate. The design is quite extraordinary. Because we're taking this data in 3D form, slicing it up before it gets passed to the machine, we can actually create structures that are more intricate than any other manufacturing technology, or in fact, are impossible to build in any other way. And you can create parts with moving components, hinges, parts within parts. So in some cases, we can abolish totally the need for manual labor. It sounds great. It is great. We can have 3D printers today that build structures like these. Well, this is almost 3 meters high. And this was built by depositing artificial sandstone, layer upon layer, in layers of about 5 millimeters to 10 millimeters in thickness, slowly growing this structure. This was created by an architectural firm called Shiro, and you can actually walk into it. And on the other end of the spectrum, this is a microstructure. It's created depositing layers of about 4 microns. So really, the resolution is quite incredible. The detail that you can get today is quite amazing. So who's using it? Typically, because we can create products very rapidly, it's been used by product designers or anyone who wanted to prototype a product and very quickly create or reiterate a design. And actually, what's quite amazing about this technology as well is that you can create bespoke products en masse. There's very little economies of scale. So you can now create one-offs very easily. Architects, for example, who want to create prototypes of buildings. Again, you can see this is a building of the Free University in Berlin, and it was designed by Foster & Partners. Again, not buildable in any other way. Very hard to even create this by hand. Now, this is an engine component. It was developed by a company called Within Technologies and 3T, RPD. It's very, very, very detailed inside with the design. Now, 3D printing can break away barriers in design which challenge the constraints of mass production. If we slice into this product, which is actually sitting here, you can see that it has a number of cooling channels passed through it, which means it's a more efficient product. You can't create this with standard manufacturing techniques, even if you tried to do it manually. It's more efficient because we can now create all these cavities within the object that cool fluid, and it's used by aerospace, automotive. It's a lighter part, and it uses less material waste. So its overall performance and efficiency just exceeds standard mass-produced products. And then taking this idea of creating a very detailed structure, we can apply it to honeycomb structures and use them within implants. Typically, an implant is more effective within the body if it's more porous, because our body tissue will grow into it. There's a lower chance of rejection. But it's very hard to create that in standard ways. With 3D printing, we're seeing today that we can create much better implants. And in fact, because we can create bespoke products en masse, one-offs, we can create implants that are specific to individuals. So as you can see, this technology and the quality of what comes out of the machines is fantastic, and we're starting to see it being used for final end products. And in fact, as the detail is improving, the quality is improving, the price of the machines are falling, and they're becoming quicker. They're also now small enough to sit on our desktop. You can buy a machine today for about $300 that you can create yourself, which is quite incredible. But then it begs the question, why don't we all have one in our home? Because simply, most of us here today don't know how to create the data that a 3D printer reads. If I gave you a 3D printer, you wouldn't know how to direct it to make what you wanted to. But there are more and more technology, software, and processes today that are breaking down those barriers. And I believe we're at a tipping point where this is now something that we can't avoid. This technology is really going to disrupt the landscape of manufacturing and, I believe, cause a revolution in manufacturing. So today, you can download products from the web, anything that you would have on your desktop, like pens, whistles, lemon squeezers. You can use software like Google SketchUp to create products from scratch very easily. 3D printing can be also used to download spare parts from the web. So imagine you have, say, a Hoover in your home and it has broken down. You need a spare part, but you realize that that Hoover's been discontinued. Can you imagine going online, this is a reality, and finding that spare part from a database of geometries of that discontinued product and downloading that information, that data, and having the product made for you at home, ready to use, on your demand? And in fact, because we can create spare parts, we're seeing that machines are quite literally making themselves. You're having machines fabricate themselves. These are parts of a rep-wrap machine, which is a type of desktop printer. But what interests my company the most is the fact that you can create individual, unique products en masse. There's no need to do a run of thousands of millions or send that product to be injection molded in China. You can just make it physically on the spot. Which means that we can now present to the public the next generation of customization. This is something that is now possible today, that you can direct personally how you want your products to look. We're all familiar with the idea of customization or personalization. Brands like Nike are doing it. It's all over the web. In fact, every major household name is allowing you to interact with their products in a daily basis, all the way from smart cars to Prada to Ray-Ban, for example. But this is not really mass customization. It's known as variant production, variations of the same product. What you could do is really influence your product now and shape, manipulate your product. I'm not sure about you guys, but I've had experiences when I've walked into a store and I've known exactly what I wanted. And I've searched everywhere for that perfect lamp that I know where it wants to sit in my house, and I just can't find the right thing, or that perfect piece of jewelry, or as a gift, or for myself. Imagine that you can now engage with a brand and interact so that you can pass your personal attributes to the products that you're about to buy. You can today download a product with a software like this, view the product in 3D. This is the sort of 3D data that a machine will read. And this is a lamp. And you can start iterating the design. You can direct what color that product will be, perhaps what material. And also you can engage in shape manipulation of that product, but within boundaries that are safe, because obviously the public are not professional product designers. So a piece of software will keep an individual within the bounds of the possible. And when somebody is ready to purchase the product in their personalized design, they click enter, and this data gets converted into the data that a 3D printer reads and gets passed to a 3D printer, perhaps on someone's desktop. But I don't think that that's immediate. I don't think that will happen soon. What's more likely, and we're seeing it today, is that that data gets sent to a local manufacturing center. So this means lower carbon footprint. We're now, instead of shipping a product across the world, we're sending data across the internet. Here's the product being built. You can see this came out of the machine in one piece, and the electronics were inserted later. It's this lamp, as you can see here. So as long as you have the data, you can create the part on demand. And you don't necessarily need to use this for just aesthetic customization. You could use it for functional customization, scanning parts of the body and creating things that are made to fit. So we can run this through to something like prosthetics, which are highly specialized to an individual's handicap. And we can create very specific prosthetics for that individual. Scanning teeth. Today, you can have your teeth scanned and dental copings made in this way to fit you. While you wait at the dentist, a machine will quietly be creating this for you, ready to insert in the teeth. And the idea of now creating implants. Scanning data, an MRI scan of somebody can now be converted into 3D data, and we can create very specific implants for them. And applying this to the idea of building up what's in our bodies. You know, this is a pair of lungs and the bronchial tree are very intricate. You couldn't really create this or simulate it in any other way. But with MRI data, we can just build the product, as you can see, very intricately. Using this process, pioneers in the industry are layering up cells today. So a pioneer, for example, is Dr. Anthony Atala. And he has been working on layering cells to create body parts, bladders, valves, kidneys. Now, this is not something that's ready for the public, but it is in working progress. So just to finalize, we're all individual. We all have different preferences, different needs. We like different things. We're all different sizes, and our company's the same. Businesses want different things. Without a doubt, in my mind, I believe that this technology is going to cause a manufacturing revolution and will change the landscape of manufacturing as we know it. Thank you.